Okay, so this is my solution to week 5 problem set. So we're given the cash flow. Let's write it up here. So it's the same value every year, which means it is a uniform series. So we've got x plus 1 plus 2 plus 3 plus 4, and then n, which is basically just x plus 5. And this value, the amount, is $2,225. We're also given that interest is 10% and it's compounded quarterly, meaning there'll be 4 compoundings per year. Because that's important because of the equation we have to use to find the effective interest rate, which is 1 plus r over m to the power of n minus 1. So plugging that in, we get 1 plus 0.1 over 4, which is the amount. M is the amount of compoundings per year, or payment period, and then to the power of 4 minus 1. So this will give us 0.1038 as the effective interest rate. So looking at part A, where x equals 1, our new cash flow will be 1, 2, 6, which is n. So the first part is end of year 0, which can also be written as beginning of year 1. So between year 0, which if you look at the diagram, is over here, no payment has been made yet. So the only payment that'll be due at the beginning of year 1 is the initial amount, which is the $2,225. And that is because it's not, none of the interest has been compounded into that yet. It's just what is due at the beginning of this year. And then as it goes on, the interest compounds into year 2, 3, 4, and so on. So the next part is end of year x plus 2, or in our situation, we end of year 3. So to do that, we have this equation, that f equals a 1 plus I to the power n minus 1 all over the interest. And this is for uniform series, trying to find the future value with the amounts given to you. So for year 3, the amount's going to be the same. So it'll be 2,225 times 1 plus, going to use the effective interest. The n is going to be 3 years here, because we're looking at the end of year 3, minus 1 all over 8. So working that out, we get that the value is $7,391.80. The next part is end of year N, or end of year 6 in our situation. So same formula basically, except we're going to change the N value, because the same value or amount is paid. Six now. 138. And this value is equal to 17,370 cents. Okay, so that's all for part A. For part B, where x equals 3, we have a new diagram here. It's going to start at 3, 4, 5, 6, 7, 8, which is N. Same amounts each year. Same thing for beginning of year 1 or end of year 0. It's still just going to be the $2,225. I know I'm probably doing that part incorrect. I tried to figure out what formula to use, but I could not find one for the because the P equals A function didn't work for this situation. But for the end of year x plus 2, or end of year 5 in our situation, same amount, different in value. So this amount comes out to be $13,686.90 for end of year N or 8, because it's x plus 5 and we have x equals 3 for this part of the problem. Same amounts being paid that year, the same effective interest rate, but it's for 8 years, all over effective interest rates, and this comes out to be $25,798.70.